Hey guys, it's Raianna, and I'm going to be talking about the derivative test and how they can be used to find out characteristics of a function. Okay, so the example that we have is for a function whose derivative is f prime of x equals x squared times quantity x minus 1 all over x plus 4, where x is not equal to 4. And then the first question we have are what are the critical points? And first of all, critical points are where the derivative of your function, which we have right here, equals 0, or where that your derivative is undefined. So we have x squared times x minus 1 all over x plus 4, and we said that equal to 0. And we have 0 equals x squared, so then x equals 0, or 0 equals x minus 1, so x equals 1. So those are our two options. So those are our critical points right here. X equals 0, x equals 1. Okay, so now next is for what intervals is f of x increasing? So what we're going to do is we have a number line, and you're going to put your critical points on there. So we have, well, this should be x not equal to negative 4. Negative 4, 0, and 1. Oops, 1. It should be x equals negative 4 because of the denominator. Okay, and so now you're going to plug in values that are not on this but in the intervals, so we can figure out what each one should be. So if we plug in negative 5, then x squared, and you're only really worried about the sign of it, so I just use positive and negatives. So plug in negative 5, x squared is positive, and x minus 1 is negative, and the denominator x plus 4 is also negative, so the total thing will be positive. So that means it's increasing right here. And then if you plug in negative 2, you get positive times a negative times a positive, which means this is decreasing, so this is negative. Then if you plug in 1/2, which is between 0 and 1, you get positive, negative, positive, which means this is also decreasing. And then if you plug in 2, you get positive, 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 which means this area is increasing. So that means that our intervals that we have where f of x is increasing would be from negative infinity to negative 4, which is not included because it doesn't exist there, and from inclusive 1 to positive infinity. Don't include that. Okay, so the next thing we're going to do is where is the local max, if any, of f of x. So what you can do is you can draw this that you have from seeing where it's increasing and decreasing and get like an estimate. So your slope is increasing all the way till you get to negative 4, but that's not there. And then it's decreasing after that, decreasing, decreasing, decreasing until you get to 1. Oh, sorry. Until you get to 1. And then it increases after that. So this is negative 4. So the local max, if any, would be at negative 4, but it doesn't exist, so there are no max values. And where's the local min, if any, of f of x? So if you look at your graph that we drew, the local min will be at 1, x equals 1. So that's it. Thanks for watching, guys.